So in the meantime then, what other kinds of things can we do with these compositions? Well, part C then says, now that we have some idea about f composed with g, let's find f composed with g of 1. Now as you look at the board then, you're going to see that I have two different options here. Option 1 starts off and says, we already have some information about this f composed with g function from part A. So from part A, f composed with g of x was the rule 9x squared minus 6x plus 1. So if we're asked to find f composed with g of 1, one way of doing this problem is to simply say, hey, we already have a rule, let's use it. So we have 9 times x squared, but our x in this case is 1. So it's going to be 1 squared minus 6 times 1 plus 1. Well, now it's a matter of going through, make sure that you're comfortable with the order of operations and you follow the order of operations. So we're going to square the 1 and then multiply times the 9, so that's 9. Then we have negative 6 times 1, that's negative 6, and then we add 1 to that. So 9 minus 6 is going to be 3, add 1, we're up to 4. So f composed with g of 1 is the number 4. But you're not always going to have a rule for a given composition. So how else can we do this? So let's come over here and check out option 2. Option 2 says we can actually use the definition of composition. So f composed with g of 1, according to the definition of composition, this is f of g of 1. And then once we know that, we can go ahead and use many of the same ideas we used in part A and think about the order of operations. I have layer upon layer of parentheses, so start on the inside. So if we can figure out what g of 1 is, then we can go ahead and plug that piece in. Well, let's go ahead and do that up here. So g of 1, well, I have a rule for g. G of any x is 3x minus 1. We're replacing x by 1 here. So this is going to be 3 times 1 minus 1. 3 times 1 is 3, subtract 1 from that, we're down to 2. So g of 1 is the number 2. So I can replace this g of 1 inside the parentheses with a 2. So now we have f of 2. But that's now another functional notation problem. I can go ahead and see that means that I'm going to put in an x value of 2 into the function f. Well, what does f do to anything? It takes my anything and squares it. So f of 2 is going to be 2 squared. 2 squared is going to be 4. So as you look at the two columns then, we end up getting the same answer. So when you look at this then, why do we need to have two different techniques? It all depends on the information that you're given in a problem. So if you happen to already know a rule for a composition, you can go ahead and use that. But option 2 is always out there, even if you don't happen to have a rule for the composition. If you have a rule for each one of the individual functions, you can still find the answer.